Okay. Welcome to this presentation where I want to deal with welcome to this presentation where I want to deal with the National Senior Certificate, which is Grade 12. Grade 12, the Republic of South Africa, which is Mathematics Paper 1 in the year 2018, written between February and March. So in this presentation, we want to do with question 2, as question 1 was already done in the other video. So if you want to find question 1, you can check in the other video. All right. So let's see our question 2. So we are saying, this is our question 2. Given the following geometric series, 30, 10, 10 over 3, can we determine n if the nth term of the sequence is equal to 10 over 729? All right, so I'm going to use a separate board. So that is the 2.1.1. So our sequence is 30, 10, 10 over 3. Okay. So want to find the value of n if the nth term, so which is Tn, is equal to Tn is equal to 10 divided by 729. Okay, divided by 7. Let me just erase this. Divided by 729. Divided by 729. So we have got 10 divided by 729. All right. So what we are saying is that find Tn. I'm going to use the general formula, which is first term by common ratio, the term itself minus 1. So this implies that Tn, which is 10 over 729, should be equal to our first term here, where A, take note, where A is equal to 30 and our common ratio is equal to 10 over 30, which is 1 over 3. Okay? Is it 1 over 3? So we are going to say this is equal to our first term is 30 multiplied by our common ratio is 1 over 3 to the power n minus 1. Okay, so we keep going. So what are we saying? What we are saying is that this is 10 over 729 is equal to 30 times 3 to the power negative 1 n minus 1. Okay? This is equal to 10 divided by 729, which is equal to 30 times 3, negative 1 by 1, negative 1 is 1 minus n. Okay? This is what we have. Okay, so, oh, sorry for that. Good. Okay, good. So what are we saying? This is equal to, we introduce an imaginary 1, you cross multiply. You have got 30 30 by 3, 1 minus n by 729. This is giving us 1 is giving us 10. So we'll divide both sides of the equation by 30 by 729. Equally here, we have got 30 by 729. Okay, so this will give us 3 to the power 1 times 3 to the power negative n. All right, this is what will remain when we divide. This is equal to 10. This is equal to, we can divide 10 into 10 to be 1. 10 here, you get 3. So you have 1 divided by 3. You can multiply 3 by 729. 729. Okay, so you're going to get 2,187 to 187. This is what we have. So this implies that you can multiply this throughout by and multiply throughout by 1/3. 3 to the power 1 times 3 to the power negative n is equal to 1/21 this. So what do we get? This is giving us 3 and 3 cancel. We've got 3 to the power negative n is equal to 1 over, so you multiply this number by 3 now. So by 3, I've got 6561. 6561. So this is equal to 3 to the negative 1 is equal to 6561 negative 1. Okay. All right. So we are going to move. Okay, we are going to move. Just a minute. Okay, so we are going to say this is 3 to the negative to the power negative n is equal to 6561 to the power negative 1 can be written as 3 to the power negative 8. All right. Take note. So this will mean that negative n is equal to negative 8 and n is equal to 8. So that is your n. You have got your n there. Okay. That is your n. I hope that is okay. Then go to the next question. 2.1 to calculate 30 plus 10 plus 10 over 3, which is the sum of the first 3 terms. All right, so we're interested in the sum, so which is 2.1.2. So here we have 30 plus 10 plus 10 over 3 plus, okay, so to get the sum, you're going to say now, take note, after plus, we have got these 3 dots, meaning that we need to find the sum to infinity, actually. So we'll say sum to infinity is equal to the first term minus over 1 minus common ratio. So our first term is 30 divided by 1 minus our common ratio, which is 1 over 3. Okay, this is equal to 30 divided by 1 minus 1 over 3. If you want to introduce a 3 over 3, I mean 2 over 3. Okay. Two over 3. So 2 over 3. This is equal to 30 by 3 over 2. So meaning that our sum to infinity is equal to 45. This is our sum to infinity. That is our sum to infinity. Okay, we go to 2.2. 2.2. What does the question state? Derive the formula for the nth terms of an arithmetic. Derive a formula for the sum of the nth terms of an arithmetic sequence if the first term of the sequence is A and the common difference is D. So we need the formula. All right, this is a something that is easy. Don't need to worry. So we have got first term, T1 is A, and common difference is D. All right, so to find the sum, we know the sum will be equal to Sn is equal to, if you have got the first term A, you're going to say plus, all right? A here, the second term will be A plus the common difference. For example, if I've got 2 and my common difference is 3, so it means here I'll say plus 2 plus 3, all right? Which will be 5, so on and so forth. So we'll say plus, you say plus, maybe we can even say dash dash plus. If we keep on moving like that, we are going to have A plus. All right, the common, the term itself minus 2, then you have got the common difference N. Okay? Plus the last term. All right, if we keep on moving like that, add the last term. All right? Now, we are saying this also implies that we can maybe call this equation 1. So we'll say Sn is equal to, we are saying, for the first term, this one, of course, the term is unknown, so we can say Tn plus, all right? This is the same as saying Tn minus d plus, what are we saying? This is the same as saying Tn minus 2d, okay, plus, you can say maybe dot, 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 plus a, and this will produce our equation 2. Now, this implies that if we can adding equation 1 and 2, what are we going to get? So when we add this side, Sn and Sn, it will give us 2 Sn. This will be equal to, when you add A to Tn, you have got A plus Tn. All right? We'll continue adding now. So A again plus Tn okay. Plus, all right? So here we can say our first term is A. If we keep on adding like that, our first term will be A plus Tn. When we add up this, all right? When we add up this to this, okay, so we have got A plus Tn open brackets. Of course, here there's a plus. We'll have Nd minus 2d minus 2d plus, can you continue adding up to some points? Then we close. Okay, plus some numbers. All right. So what is simply happening here is we have 2 Sn is equal to, so we are just repeating this. So we have got n plus a plus 2 n Tn. Okay, now then plus a plus Tn plus a plus Tn plus A plus Tn is plus A plus Tn, all right? Now, you realize one thing here. What is that we are realizing? So A plus Tn keeps on being repeated, all right? Okay, so we can divide both sides for 1 by 2. Okay, let's change the color. So can divide both sides maybe by 2. So this implies that we have Sn being equal to A plus Tn plus A plus Tn plus so on and so forth plus A plus Tn. Can shorten it like that. If you want, you can write everything. This should be divided by what? By 2. So Sn is equal to now maybe before we can even proceed, we can emphasize something here. Let me just erase that. And emphasize something here that this will imply that our Sn will be equal to here. We don't know how many these are. You can have as many as they are. So you multiply by a certain number. All right, so we're going to say n, I don't know how many there are, by A plus Tn. If there are 3, it will be 3 by that. Divided by what? 2. But we need to remember that the general formula for Tn is equal to A plus n minus 1 d. This one I think we remember. All right. So that is a general formula. So what that means is that we'll say Sn is equal to n, open bracket, A plus. All right. What are we saying? A plus 1, we can do this. Okay, sorry for that. So we have n minus 1 d. Everything should be divided by 2. So this implies that we have Sn is equal to n, open the bracket, A plus n minus 1 g. This is divided by 2. So what does this mean? This implies that Sn is equal to n, open the bracket, 2A plus n minus 1 g, everything divided by what? 2. All right, and that's the formula. Hence, shown or derived. Okay, thank you, and please subscribe for more videos. Can you WhatsApp me on 0978565876 or a friend of mine on 0979673809. Thank you, and till next time, shalom, shalom.